Okay, so we want to integrate the double integral over r of x times sine of y dA. R is bounded by y equals 0. Okay, what is y equals 0? It's the x part of the x-axis anyway. It's going to end up being, right? Y equals 0 is the whole x-axis, but it's going to, the other boundaries will cut it off. Y equals x squared and x equals 1. Super important to draw it if you're going to come up with the correct limits of integration. So let's do that. So here's my x-axis, here's my y. If I draw on the parabola y equals x squared, I usually just go for a sketch unless I have to be incredibly accurate here. X equals 1, I guess I could put x equals 1 out here, right? But x equals 1 in the plane is really a line, right? Vertical line. So try and draw it straight up. It's going to intersect somewhere. Actually at 1, 1, right? Because we know that y equals x squared goes through 1, 1. And then the x-axis then, there's the third boundary, right? So it's bounded above by the region R is this guy in here, and it's bounded above by the parabola y equals x squared. Let me put that in there. It's bounded below by y equals 0, the x-axis. It's bounded on the right by x equals 1. Everybody see that? I can't, you know, it's a vertically simple region, right? It's also horizontally simple, but the default is to integrate with respect to dy first, or y first, and then x, which corresponds to the differentials dy dx. So unless it's difficult to do that integral, that's what I'm going to default to. If it turns out to be easier to integrate with respect to the differential or dx dy, then I'll do that. But for now, I'm going to set it up dy dx. The integrand is x sine of y. And then what does the inner limits of integration go from? So if you draw in a vertical rectangle, might look like that. So the function that gives the lower end of that rectangle, which is a constant in this case, is the inner lower limit. The function that gives the upper part of that rectangle, the upper end of that rectangle, the top of it, in other words, is your upper inner limit. So what are those? 0 to x squared. And then what does x run from? Think horizontally here. 0 to 1. Okay? Is it going to be hard to integrate with respect to y? Nah, I don't think so. I think it'll be fine. So we'll integrate first with respect to y, so we'll keep the outer integral here. X is just a constant with respect to y, so you have to integrate sine of y. What's that? So I'll put the negative out front. We still have the x cosine of y. Now we have to put in the evaluation brackets. We have to evaluate that from 0 to x squared. And then dx, because the dy is gone, right? Now, plug in the upper limit. What do you get? X times, I'm going to switch to parentheses, x times cosine of x squared. And then minus cosine of 0, what's that? 1. And then that's a dx. Everybody see that? And then it's going to look vaguely like the last problem. If we distribute, we get what? X cosine x squared minus x inside. Yeah? Does everybody see why it really does kind of look like one of the integrals from the last time? Because how are we going to integrate this guy? U sub, right? U sub. So let's try not splitting up the integral this time, see if we like that way better, right? Try different ways of doing things. So what would u be in this case? X squared and then du? Well, here's the problem with not splitting it up then. How do you put in the 2 and then multiply by 1/2 when that stupid minus x is there, right? So I'm gonna go backwards on what I just said. Let's go ahead and split the darn thing up. Now, you do have to be careful. There's a minus out in front of the whole thing, right? So it would be really easy to mess up the sign on the second integral, wouldn't it? So you could distribute the minus back into the integrand if you wanted to really be careful. So that would look like the integral from 0 to 1, and then this becomes negative x cosine x squared plus x, right? dx. And then it would become the integral from 0 to 1, negative x cosine squared, cosine of x squared rather. I'll bring that negative back out front because I'm splitting up the integral. X cosine x squared, and then plus integral 0 to 1 x dx. Does everybody buy that? Did I need that step in between? No, you could have done that in your head, but if you wanted to be really careful. And then don't forget the dx notation like I just did. All right, so then we do need we need a 2x to have a perfect du, don't we? Which means we multiply by 2, and then inside and 1/2 on the outside. So this is really the integral of cosine of u du, if you think about it. And with the negative 1/2 out front. So what does that turn out to be? Negative 1/2. Take the antiderivative, what do you get? Sine of u, which is x squared, evaluated from 0 to 1, and then we might as well do this guy at the same time. 1/2 x squared evaluated from 0 to 1, right? Yeah? Okay. And then what does this guy turn out to be? Negative 1/2 out front. Sine of 1 minus sine of 0 is 0, right? So I don't even need those parentheses. 1/2 sine of 1 plus just 1/2. When you plug in the 1, you get 1 here, then 0, 0's out. Minus 0, 1/2 out front, so just 1/2 times 1. How did I write it? I don't know. If I factor out the 1/2 and turn things around, I bet I wrote it as 1/2 times the quantity 1 minus sine of 1.